Hello students to MJC Learning. My topic is thermodynamics. Thermodynamics deals with the macroscopic property of a system, that is measurable properties of system like pressure, volume, temperature, density and mass. It doesn't deal with microscopic property. For that we have another topic called statistical mechanics. In our topic we will be mostly discussing about gas. So students, you have already known this equation PV is equal to nRT. This is an ideal gas equation and it is also called thermodynamic state equation. But why is it called thermodynamic state equation? Because it has state variables. Now what is this state variables or thermodynamic state variables? The measurable property which are required to describe the state of a system are called state variable. Example: temperature, pressure, volume, density and mass of the system. Here two graphs I have shown. One graph shows a point -3, 2 which shows the position of the point, whereas another graph is P and V graph where initial position of the system is shown, or initial state of the position is shown by P1 and V1, and its final state is been shown by PF and VF. So state variables represent state of a system like initial state and final state. But state variables gives only information of state and cannot be measured at any instant during the thermodynamic process. So one can easily say that it describes the system only when it is in thermodynamic equilibrium. Now, what is the thermodynamic equilibrium and what are the types of state variables? Let us see. What is thermodynamic equilibrium? When a system is in mechanical equilibrium, chemical equilibrium and thermal equilibrium. Mechanical equilibrium, you know that when all the forces acting on the system will be zero. Chemical equilibrium, when there will be no chemical reaction inside the system. Thermal equilibrium, when there will be no flow of heat from one part of the system to another part of the system. Now there are two types of state variables: intensive and extensive variables. Intensive variables, it does not depend on the size of the system. Extensive variable, it depends on the size of the system. Their examples are given below. Next is explanation of intensive and extensive variable. Let us consider a system in equilibrium. Now let us divide the system in system A and system B with original volume into half. So we will observe that pressure, temperature and density will be same in both the compartment. These are called extensive variable. Whereas total mass, internal energy of the system are equally divided into two compartments and are extensive variable of the system. Next is we will be learning about first law of thermodynamics. To understand first law of thermodynamics, you need to know internal energy, work, heat and temperature. Concept of work will be explained a little later. So let us understand first internal energy, heat and temperature. Internal energy is defined as the energy associated with the random disordered motion of the molecule of the system. Example: glass of the water kept on the table has no kinetic energy because it is not moving, and its potential energy is also be taken as zero. But molecule in the glass at a given temperature moves at a random speed. I am going to repeat it again, student. But molecule in the glass at a given temperature moves at a random speed. Thus we can say that internal energy of a substance is the total energy of all its atom and molecule. Depending upon the molecule, it will have its kinetic energy. As you have seen, it is moving at random speed, and we also know kinetic energy formula is half mv square. So if it has some velocity, then it will have some kinetic energy also. Depending upon the molecule, type of molecule, it will have different types of kinetic energy. Like monoatomic molecule will have only translational kinetic energy. Polyatomic molecule will have rotational, translational and vibrational kinetic energy. Now summation of all this kinetic energy will be zero if the system is not moving. And next is heat. Heat is something that is transferred from a substance at higher temperature to that at the lower temperature. Temperature is one of the basic SI quantities. Okay, but you also have one question here. Internal energy and heat are both type of heat. What is the difference between them? Heat is the energy in transit or moving energy, whereas internal energy is not a moving energy. Next is how you can change the internal energy of a system. There are two ways, one by heating it or one by doing some work on it. As you can see in the diagram, students, there is a cylinder provided by a movable, massless and frictionless piston at one end. The gas inside the cylinder is our system and the rest is its environment. Let the temperature of the gas be Ts and that of the environment be Te. The cylinder can be brought in contact with the source of heat such as burner. The temperature difference between the source of heat and the system will cause the flow of energy towards the gas in the cylinder. This is because temperature of environment is greater than temperature of system. Thus there will be increase in internal energy of the gas. So change in internal energy can be brought by doing some heat, providing some heat. Next is how it will be changed by doing some work on it. So if we quickly push the piston inside the cylinder so that the gas is compressed, in this case we know that piston does some work on the gas in moving it through some distance. The gas gains energy and its temperature is increased. On the other hand, if the gas pushes the piston out so that the gas is expanded, some work is done by the gas. It loses some of its energy and the gas cools down. So there are two ways to increase its kinetic energy, internal energy. One is by heating it and one by doing work. We have to remember only this one topic, that internal energy can be increased by either providing by heat or by doing some work on it, or doing some work on surrounding by the system. First law of thermodynamics, it basically what wants to say is that energy cannot be created, cannot be destroyed. Energy provided to the system will be used to do some work and to increase its internal energy. This equation delta Q is equal to delta U plus delta W. Let us define this delta U, delta Q and delta W. Delta Q is heat supplied to the system by the surrounding. Delta W is work done by the system on the surrounding. Delta U is change in internal energy of the system. So the energy supplied to the system goes in partially to increase the internal energy of the system and the rest in work on the system. First law of thermodynamics explains the conservation law of energy. Energy cannot be created and cannot be destroyed. If you provide some energy to the system, that is heat to the system, it will do some amount of work and it will increase its internal energy. So your energy will be utilized in these two ways. Depending upon this equation, delta Q is equal to delta U plus delta W, we will be solving a lot of equations and we will be deriving its mathematical form. Actually it is mathematical form. We will be deriving its mathematical form in the next topic. Thank you.